Hello guys, welcome back once again. This is lesson 15 on recursion. Once again, this is more advanced recursion, so if you haven't seen the previous recursion lesson, I strongly recommend watching that first. First thing I want to do right off the bat, at the end of the last lesson I said that tail recursion was great for Java, and it's something you should know. Well, as it turns out, that was completely wrong. And the reason I thought that, honest to God, I had a computer science professor in college that told me that Java was good at handling tail recursive methods. Apparently it's not, because I just did some tests and they didn't work, but we're just going to go over tail recursion real quickly. Here is Wikipedia. Okay, tail recursion is pretty easy to understand. Basically, it means that it's recursion when the last operation of a particular function is the recursive call. And that just means you say return and then the function name, and you change the parameters somehow. So as we saw with factorial or with the tripler functions, they said like return 3 times the recursive call, or return n times the recursive call, or whatever. That was not tail recursion, because the last operation it did was actually do that mathematical addition or multiplication. But in real tail recursion, the very last thing it does is that recursive call. And what you see here is replacing recursion with iteration can drastically decrease the amount of stack space we use and improve efficiency. So we talked about that in the last video. Now the problem is Java doesn't do that automatically. So if you ever have a tail recursive function in Java, you've got to manually convert it to iteration, which is pretty easy to do. But I thought the compiler handled it automatically for you, but when I tried it out, it actually didn't work. So I'm going to show that to you real fast. I wrote this little function called sum2digit, and basically all it does is it adds up the digits from 1 to n. So if the integers, not the digits. So if I run sum2digit on like 4, it's going to be just 4 plus 3 plus 2 plus 1, which will of course be equal to 10. So the way that works is I start out asking for just that n, and then what I have to do for tail recursion is use this helper method. And the reason I need a helper method is because I've got to pass a default parameter, which is just 0. So the client comes in and all he knows about is this sum2digit function. So he calls it, puts in a 4, and then this guy says, well, okay, I actually need to call this function and stick on that 0. So what I have here is the helper function, and that second parameter is called so far. So like, what is the sum so far as we're going through and adding all these numbers up? So if we get down to 0, then instead of returning 0, we're going to return so far, because we've been adding those up and we keep track as we go along. So we keep track of those numbers, and once we get to 0, we're just going to return that value. And if n is not equal to 0, then we're going to call the recursive function here, sum2digit helper, once again, but instead we're going to pass in so far plus n. So if n is 3, then it's going to add 3, then the next one n will be 2, because we're going down one by one, so it'll add 4, 3, 2, 1. So finally, so far will equal the result, and then n, when that happens, n will be 0, so it'll just return so far, so that gets returned up here, and that gets returned up here. So let's compile that. And of course, sum2digit for 4 would be 4 plus 3 plus 2 plus 1, which is 10. So that is tail recursion. Congratulations. You may see these helper functions a lot. You might need them. If you ever need some kind of default parameter, that's the way to do it. Other languages like C# now and PHP and Python, you can actually provide default parameters, so you don't need to have these helper functions. But that's neither here nor there. This is Java. Okay, so next thing we're going to do is learn how to think when you're writing a recursive function. And I've never been taught this particular method. I mean, somebody else has probably thought of it, but I'm the only person that I know that has actually thought about it, and I came up with the easiest possible way I could think of to explain to somebody how to write a recursive algorithm. So let's get rid of that. Push that down for now. And let's get rid of this here. Okay, so there's 3 easy steps. And once you master, and I mean really master those 3 steps, then you can write any program. You can write any kind of recursive algorithm you need. So step 1, we've already gone over step 1, which makes it even easier, is you need your base case. Let's actually do this here. Nope, didn't want that. Alright. So, base case. That is the first thing we need. That is the simplest possible case for your recursive algorithm. We already showed that in the triple function. Base case was where n equals 0. In the factorial function, it was n equals 1. And in the Fibonacci algorithm, we actually had 2 base cases. One where was n is equal to 1, and the other one is n is equal to 0. It's possible to have more than one base case, but as long as, well, we'll get to that in a second. Second, you need to figure out how your recursive call is going to get closer to your base case or base cases. So in the triple function, n kept subtracting 1. So every time we recurse, n gets smaller by 1, and eventually it got down to our base case, which was where n equals 0. So that's the question you got to ask yourself. How is my recursive call getting the parameter closer to the base case? And this is why you might want more than one base case. If your recursive call doesn't, if you have more than one recursive call, or if the recursive call doesn't always get to one particular base case, you might need to create more than one base case. But as long as your recursive call somehow gets down to a base case, then you're good. So what should we say? We should say get closer to the base cases. And the third step is I think it's the hardest step of all. And what this is how is the answer to a simpler problem going to help you out with the current problem? And that's kind of hard to explain without using an example, so we'll just go back to the triple function from the previous video. In the previous video, we saw that the answer to the previous problem, which was, let's say, for example, we pass n equals 5. So if we want a triple 5, we want the answer to n equals to triple of when n equals 4, because that's one step closer to the base case. How does that help us answer when n equals 5? Well, when n equals 4, the triple of 4 is 12, and the triple of 5 is 15, which means, of course, we need to add 3. So 3 plus the triple of one step closer to the base case is equal to the answer to our problem. So that was for the triple. For factorial, it's just about the same. If we get factorial of n minus 1, then if we just multiply that by n, that means we have factorial of n. So that's basically how that works. How does the previous how does the previous call help us determine the answer? If we can answer these three questions, and I'm not saying they're easy questions, but if we can answer all three of them, then you can write any recursive algorithm, which is just awesome. Like I said, 3 is probably the hardest. 1 is so easy that you'll overlook it. You'll think it's, you'll think that it's something that's more complicated than it really is. And 2 kind of goes along with 3, but you gotta know when to stop. Otherwise, you're just going to have that Stack Overflow error because it won't ever stop. It'll keep pushing those activation records, and it's almost like an infinite loop, except you keep using up more and more memory. Alright, so the function we're going to write is a recursive function. Not going to be obvious, once again, but it'll be great practice. So this one is going to be a string reverse. Pretty easy to do. I think the string class already has a reverse method, but we're just going to write one recursively for fun. I ran out of my cran strawberry juice. So. Okay. Oh wait, static string reverse string s. Okay. So we're going to reverse s. So if we pass in race car, it's going to come out race car, right? Okay. So let's go through these 3 steps, and I'll show you how it makes it so easy to solve any recursive problem you've got. So let's say the base case, right? Well, once again, you need like the easiest possible answer to this. So if s is the empty string, then the reverse of nothing is nothing. So if s dot equals empty string, then we're going to return the empty string, right? Let's get rid of those. Okay, now what's next? Get closer to the base case. So how can we get, if we have an integer and the base case is when that integer is 0, then if the integer is positive, then we can always get closer to the base case by subtracting 1 each time, or maybe dividing by 2 each time. Somehow we're getting closer to the base case. For a string, we have to do something else. Most obvious thing, in my opinion, to get closer to the empty string is to just remove 1 character at a time. And as it turns out, that's what we're going to be doing. This down here is an example of how our algorithm is going to work. Okay, so if we start out with a word, warts, and we remove the first character in the recursive call. So the first time it's going to remove the W, second time it's going to remove the A, third time it's going to remove the R, then the T, and then of course the S. Once it gets to the empty string, then whoopsie. Once it gets to the empty string, and now I want to put those letters back in the order that I remove them off. So I'll put back the S, I'll put back the T, then the R, then the A, and the W. So we reverse warts, and it becomes straw. So that's kind of that's going to go with number 2 and 3. So else get closer to the base case. So let's create a new string, part equals, and we need s dot substring. That's going to take off the first letter, and I'm going to be left with just part. And we know that this will work. We know that this will work because we know the string is not empty, and therefore we can't, then the one index exists. You know. So we have to remember that first character. So char first equals s dot char at 0. So that's the first character, and then we get the rest of it with this. And now we've taken care of 2. How does the previous call help us determine the answer? So if we're getting closer to the empty string, and then every time we want to put back, we have the empty string, right, and we want to put back another character. So let's say, I think we can go ahead and return, and we say reverse part plus first. So now we have this partial, and we reverse that, and then we just plug on the first character. And so how does the previous call? So if we reverse that last part of the string, that helps us determine the answer, because then it's just that first character appended onto the end. So I think that's good. Let's go ahead and reverse. Let's go ahead and do a couple of them. Okay. And I think we can go ahead and hey, look at that. So it successfully reversed that, and it reversed that, and race car reversed is of course race car. And we can even do our clever little palindromes like to hot, to hoot, which is one of my favorites, or go hang a salami. Go hang a salami. I'm a lasagna hog. Too hot to hoot. So if we ignore the spaces, then of course that's just great. So hey, look at that. These are my rules here, which if anybody's ever having trouble with recursion, I just tell them these 3 rules, and you know, so they give me a problem, and I'm like, okay, well, your base case, you got that. How are you going to get closer to your base case? Okay, we figured that out. How does that previous recursive call help us in getting the answer? Once we answer those questions, write a few lines of code, and there's the answer. So with recursion, you can do all kinds of powerful stuff. One thing I did, which sure, why not? I'll show you now. It's a Sudoku solver for PHP. So let me just find that real quick. Okay, I found it. I'm just going to show you what it does real fast. It's like a little web app. I did it in PHP, not in Java, so I don't know a Sudoku I can put in, but let's just put in all zeros, so it'll give me like the first thing it can come up with. 0 means just like a blank space, so I'll say solve. So I gave it a blank board, and then this is the first solution it could find, given a blank board. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 4, 5, 6, 7, 8, 9, 1, 2, 3, right? So just bam, right? Pretty easy. And I'll show you where the recursive call is, even though this is PHP. Solve Sudoku, this is just a function in PHP, and see, look, here is my recursive call. So solve Sudoku, we're inside this function, and I'm calling it here. Pretty cool. You could do that in Java if you really wanted to. Here's a good task. It's a pretty difficult problem, but if you think about it, I'm pretty sure you can do it. So I'm not going to tell you how to set it up, but I'm just going to tell you how it's going to work. So say I give you a list of numbers, right? Being any number of numbers. They can be integers or floating point values, you don't know. And then I give you a target number. So you have this big list, who knows how long it is, it could be 5,000 elements, and you have a target number. And I want you to find which set of numbers out of that list add up to the target number, right? So if the list I give you is like that, and I say the target number is 32, then find which numbers in this list add up to 32. And I just looking at that, I don't know. There probably is probably multiple ways you could do it, but just find the first set of numbers out of this list that will add up to 32. And you can do that using recursion. And it's pretty difficult, but if you can answer these 3 questions, then I don't see why not. So that's your assignment for this particular lesson. And with that, I think we're done with recursion. We're definitely going to visit more recursion when we go over some recursive data structures, which are pretty cool. And that's all I've got for now. So thanks for watching, and yeah, that donate button over to there, I think. Yeah. Or maybe you have to click back and then it's over there. Yeah, click it and put in some big values with lots of zeros and be good. Thank you. Bye.